Welcome back, dear students. In today's session, we are going to continue with quadrilaterals. We are going to see few important theorems. But before we go for that, you all must recall what you learned in the last sessions. So in the last session, I explained you the properties of different types of quadrilaterals like trapezium, parallelogram, rhombus, rectangle and square. So you recall all these properties. This will help you in understanding the theorems. Along with this, you must also recall the congruency rules which we learned in the previous chapter. How many congruency rules we learned? We learned 5 congruency rules. One was SSS. Then we learned side angle side, AAS. We learned about ASA, and we learned about RHS congruency rule. So these all the congruency rules are used in chapter quadrilaterals also. Along with that, CPCT. Okay, so we applied these congruency rules and CPCT in triangles. You got a good practice of this. So recall this all. This will help you in understanding the theorems. Let's begin with the first theorem of this chapter. In this theorem, he is asking you to prove that a diagonal of a parallelogram divides it into two congruent triangles. So you can see the figure. I have taken a figure, parallelogram ABCD, in which AC is the diagonal. Okay, we have to prove that this diagonal AC divides this parallelogram into two congruent triangles. Imagine you have a piece of cloth, or you have a cardboard sheet in parallelogram shaped, and if you cut it diagonally, this diagonal will divide that sheet into two congruent parts. Okay, one will be ABC, another will be ADC. How we can prove these two triangles are congruent? Let's see that. So we know that opposite sides of a parallelogram are equal. Opposite sides of parallelogram is parallel also. Okay, so we know that AB is parallel to DC and AD is parallel to BC. We learned this in properties of parallelogram. So when these two sides are parallel, I can say this, if AB is parallel to CD, and I can say this AC is the transversal here. Okay, so when AC is the transversal, I can say these two angles are equal or not. They are alternate angles. Okay, in the same way, when AD is parallel to BC, this AC is transversal again here. So I can say this angle is equal to this angle again. Okay, so I can say these are also alternate angles. So I can use this property and prove that these two triangles are congruent. Or I can use other properties also. I can say that these two triangles are congruent. I can prove by SSS congruency. I can say this is equal to this, AD is equals to BC, and I can say this is equal, this is common part. So these two triangles are congruent by SSS congruency also. So let's prove by any one of the rules. So here AB is parallel to DC and AC is transversal. So I said angle BAC is equal to angle BAC. This angle is equals to angle DCA. Okay, they are alternate angles. In the same way, we'll get another pair of alternate angle. This angle is equals to this angle. Okay, so we have got this is equals to this and this angle is equals to this. We have got two angles of this triangle equal to two angles of the other triangle. Okay, now I need one more part to prove they are congruent. So that one more part will be AC. So first is BAC is equals to DCA. Okay, from 1 we have taken. Then AC is common here. AC is equals to AC, and DAC is equals to BCA. Okay, DAC, see this angle, is equals to BCA. They are also alternate. So finally we can say that these two triangles are congruent by ASA, because two angles and one side of this triangle are equals to two angles and one side of the other triangle. so they are congruent by ASA congruency. You can prove this theorem even by SSS rule also, as I said you, okay, even that is also correct. Now let's go for the next one. In a parallelogram we have to prove that opposite sides are equal. Okay, I explained you this concept here because this will help you in second theorem also. So we have to prove that opposite sides are equal here. Okay, here we don't know that opposite sides are equal. Okay, this is a theorem, we have to prove that they are equal. So I cannot take that the sides are equal in our proving. So again we'll do the same thing what we did for the first theorem. I'll take this as a transversal and these two angles are equal. BAC is equal to DCA. Similarly, this is a transversal, so I can say these two angles are also equal. Same thing we are doing here also. Now let's see how we can prove. Again I am using ASA congruency rule here. Okay, there is no difference between the first and the second theorem. Okay, now I prove that these two triangles are congruent. So I can say by CPCT now that the opposite sides are equal. So I can say when these two triangles become congruent, I can say that AB is equals to DC, AB is equals to DC, AD is equals to BC. Hence it is proved that opposite sides are equal. So by using congruency rules we can prove different theorems of this chapter. Let's go for the next. It's saying that if each pair of opposite sides of a quadrilateral is equal. Okay, imagine ABCD is a quadrilateral in which AB is equal to DC and AD is equals to BC. Each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So this is not a parallelogram now. It's looking like a parallelogram, but we have to prove that it is a parallelogram. So for that I'll join AC. AC is the diagonal here. We know what we know. We know that AB is equals to DC. I can use this in proving. AD is equals to BC. So I can use this in proving. Here I cannot use alternate angles. Okay, because we are not sure whether it is a parallelogram or not. Now in triangle ABC and CDA, here we are using SSS congruency. You can see here. So AB is equals to CD and BC is equals to DA. It's given to us and AC is the common part, so we can say that these two triangles are congruent by SSS congruency rule. When these two triangles are congruent, I can say the angles, this angle BAC is equals to angle DCA, CPCT. Then I can also say this angle is equals to this one, that is also CPCT. Okay, when these two angles are equal, pairs are equal, then I can say conversely, I can say when these two angles are equal, I can say DC is parallel to AB, right? Then in the same way, when these two angles are equal, I can say AD is parallel to BC. Okay, when AB is parallel to DC and AD is parallel to BC, we can say that this quadrilateral is a parallelogram. You can write here, therefore ABCD is a parallelogram. Okay, next theorem. In this theorem we have to prove that in a parallelogram opposite angles are equal. We learned this in properties, that in a parallelogram opposite angles are equal, opposite sides are equal, but these all can be proved also. Okay, so we are doing the same thing in this now. 8.4 theorem, we have to prove that in a parallelogram opposite angles are equal. So for that we will take a parallelogram ABCD in which AC is the diagonal. You can observe in all the theorems we are taking the same type of figure. Okay, only the RTPs are changing, required to prove are different. Okay, we have to prove angle B is equals to angle D. Opposite sides of a parallelogram are equal, so you can prove this by the previous method again. Okay, so here you can use the same procedure, this procedure. Okay, you can say that copy the same steps here. Okay, the same procedure can be used here. I can say that side AB is equal to side DC in triangle ABC and triangle ADC. We say that side AB is equals to side DC because opposite sides are equal. Then I can say AD is equals to BC. Okay. To prove this thing, I need to prove these two triangles are congruent. Then I can say that by CPCT. Then last is AC is equals to AC. So therefore I can say this triangle ABC is congruent to triangle ADC. By which property? By SSS rule. So when these two triangles are congruent, can we say angle B is equals to angle D or not? Yes, we can say that angle B is equals to angle D. Why we can say angle B is equals to angle D? They are CPCT. Okay, corresponding parts of congruent triangle. Similarly, I can say angle A is equals to angle B also. Yeah, I can also say angle A is equals to angle C. Sorry, this angle is equals to this angle. For that, you need to draw a diagonal in this way. So you can write even similarly. So this is the way we can prove different theorems. There are different ways of proving it. You can follow any one suitable way. So complete all the theorems in your classwork.